In this exercise, we're going to look at the volume and surface area of a cylinder. Okay, so we know that the volume of a prism is the area of the cross section, which in the first picture is this area A here, multiplied by the length. And a cylinder is a prism as well, so we have the same sort of formula. We work out the area of the cross section, that's the circle, multiplied by the height or the length. But it's exactly the same as the area formula for a regular circle, so we can replace the A with pi r squared. So the volume of the cylinder is pi r squared h. Okay, so let's have a look at what a total surface area perhaps could be rather than the volume. Now, if you think about a cylinder, it has three surfaces. It has the circle at the top, and you can see this one has a diameter of 9 centimeters, a circle on the base which has a diameter of 9 centimeters as well, but it also has the curved surface area around the outside as well. We've got to work out the area of each of these things separately. So look at the following diagram, it gives you some indication of how we're going to do this. So the circles, first of all, well, the radius of each one would be 4.5 centimeters. So to work this out, we would do 5 times 4.5 squared, pi r squared. Exactly the same process for the base. That's going to be pi times 4.5 squared as well. So let's work those out. So pi times 4.5 squared is 63.62 centimeters squared. So we've got that there. We've got another 63.62 centimeters squared there as well. The curved surface, if we imagine unraveling the label from the can, will be a rectangle. Now we know that the height of the can was 13 centimeters, so we've got one length, but we still have to work out the other length of the rectangle, and that of course is going to be wrapping around the circle. It's going to be the same as the circumference. So to work this out, we're going to do pi multiplied by the diameter, which was 9. That's the formula for circumference. So if I do that, we get 28.27. So this rectangle is going to be 28.27 multiplied by 13, and we get an answer of 367.57 centimeters squared. So the total surface area is adding all three of these together. So if I add to that 63.62 and then another 63.62, we'll get our final answer, which is 494.8 centimeters squared. And that is the total surface area of the can. Let's look at another example. So this time we're going to find the surface area again, and we're going to find the volume. So let's find the volume first. This seems far more appropriate. We'll keep it in terms of pi for our calculation this time, and then work out in decimal at the end. So the volume, first of all, we need the cross-section area, which is a circle, and that radius is 3, so it's pi times 3 squared for that area. And then, of course, the formula says we multiply by the height. So we're going to get that answer and times it by 8. So if I do pi times 3 squared times 8, I, of course, are going to get 72 pi. Converting that into a decimal is 226.2. Now, we're in terms of a volume, so it's centimeters cubed. Now, as you can probably work out yourselves, the area of the circle is pi times 3 squared, so that's pi times 9. So when I'm calculating the surface area, I've got 9 pi for the base, I've got 9 pi for the top as well. So all I now have to do is work out the curved surface area again. Now the curved surface area is going to be a rectangle, as we recall from the previous example, and we're going to do 8 multiplied by the circumference of the circle. And the circumference is pi times diameter, so that's going to be 6 times pi, or 6 pi. So the curved surface area is going to be 48 pi. So if I add to 48 pi, 9 pi and another 9 pi, I'm going to get my total to be 66 pi, and that is the total surface area. Converting that into a decimal will give me 207.3 centimetres squared. And that is all we need to complete the exercise. Good luck.